and nice to meet you to this new episode of Wickbit. On the kitchen table we have a well-known machine. Incidentally, I got a second one, so is the RX-E810, well known now from my viewers. And incidentally wise, at the moment the spare parts are not coming here. I don't know why. I'm waiting now for 1 week, 2 weeks and 4 weeks, 6 weeks and 8 and more weeks on the spare parts for the old machines. But let's have a look inside what's happened, or we can test it. Now here's the power supply connected here, and nothing. I have no power switch on the backside. This is also interesting. No, no power switch on the backside. We must open the machine. Now I would like to open this machine, and here we are. We don't have a coffee cup or stuff like this, or a pudding cup. And we must put the screws now here. This is not good, but what shall I do? Now at the moment I have no chance in front of the camera that I have the possibility to go out in the kitchen and doing my video here at the same time. This is near impossible. I'll show you this, how to open it. On the back side they have black ones, and on the side there are silver ones on the silver machine. I don't know why they do this. I think so they have it from the black ones on the back side. Also on the side, we must know. Now we have this here to open, and this assembly the case or the box or the body, whatever you would like to hear. It's hot today. I think so, 26 degrees, and if you're making this job doing videos in front of the camera, it's hard. So it's open. Let's have a look inside. Why the machine doesn't work. He told me something about a capacitor or stuff like this. Is this maybe here? So look inside, interest. Power supply, transformer, we know that well now. And here is the second power supply, but they should bring out energy too. We must measure. We must measure now the fuses, and then we check up. Here is the measurement instrument, and we measure it here. Here are 2 fuses. Disconnect the power. This is important that you disconnect the power. Here we are disconnecting the power, and we have here 1 fuse is okay, and the second is also okay. Sounds like good. Sometimes this blue one capacitor is defect, but we must have a watch on it, what's happened with that. Switch this off, and we must build that out. It's much complicated, but I do that one time, and so I know it. It's a what shall I say, how they build this machine. It's not serviceable. I mean, you're doing a service, but here we are. We do this out, do this screw out, and now we must lift this up from here, and it's not easy to take that out. Maybe I take this. Zack. So and now it's first of all, what we must measure is this transformer here. It could be defect in case of interruption, because this is 24 hours and 7 days a week online. We take the measurement instrument here. You can see it, I hope so. But on this measurement instrument we must know the 3 kilo ohms primary and 29 ohms on the second side. Okay, that sounds good. Oh, this C12. Sometimes it's the C12 defect, but I don't know why. We can put it out and check it out. Maybe other. Oh, here was somebody inside and doing this connections here. This is interesting. What is this for? A solder joint. And doing these small little lines here. What is happened? Means that check or not check? Or what does that mean? We put that out. I make a measure. Show you that only here. We have a 370 degrees. Temperature is increasing. I put that now here on the back side in case of that I have not so much space here. And we put that number C12 out. Here we have a small hole. We put it out and we are put this out. Look. You cannot see it. 103 is written on it. Maybe I can put it in a position where you can read this. 103. No, it's impossible, I think. It's so flickering or stuff like this. 103. This means 103 means 10 nano. 10 nano. What we can do is we can make measurement points here and here, that we can measure the power supply is going inside here or not, or we can measure it here. Should we measure it here on C4? Maybe C4 have a short. C4 have a short, then 18 kilo ohms. No, it's not a short. It's more than enough. This is, I think, so the first capacitor on here after this rectifier, and there is something wrong. But what? We can put a measurement point here and watch what's happened with this. We are doing aligning here 2 points. We're soldering 2 points here and measure it. Or should we do that? Look here. This is super to measure, including polarity, and we are hands are shaking, I don't know why. Maybe I think so. This is the ground. Could that be? This is the ground. We must insert the board. Yeah, this is the ground. We must insert the board and measure it outside how much that have. And here we put the ground on it, and here we put the plus on it. So we must build it in and bring it in position. We must assemble it. Now we're doing the assembly, and oh, it's in the wrong direction. Oh, maybe. That's no good. But desoldering it, bring it to the other side, solder it, and now it looks better. The direction of the wire was wrong, so must go back. And now we must bring them in. We are driving without the seat valve. I'll show you this in the service manual. Is it possible or not? I don't know. And we should measure it. Oh, we have inserted. Okay, super. This is good. Measure it here. And now we should switch to volt and insert it to the mains, but no insert. And it's on the second side. It's on the secondary side. You can hold here. You are not on the power, and we measure 0, but nothing volt. Not much, huh? This is interesting. Why? Why it is so? Yeah. The power supply connector is here, and come in here. We go over this rectifier diode. If it's plus, go here with the transistor. It's minus to this point. And on the other side, here the output. This is the opposite. Here's the output. Will be run over this transformer. This is the second power supply. Goes here back and back here and to the line back here. You can see it. And the second transformer is for the second supply here with this rectifier on the secondary side. And the master switch is here. If this will be over this line, you see that here, if this relay will be click, then the amplifier is on. In case of that, the power transformer is here. You see the power transformer here. Then the high power is on. And I measure here, the Q1 is high. I insert here 7.6 volts and making the clock with a generator. I'm sending here in a 25 Hertz, and I'm holding the data with one pin low. In case of this, if this diode is on the second side, opening this transistor, it switches to low. That means Q1 goes the next clock low. It's over this 50 Hertz line coming from this capacitor. Herein will be limited by this diode. This is a set diode, 10 volts and minus 0.7. It's around, here is 7.6 volts. A stabilization here, and this is the power up. If the transistor is close, so the light is not here, then the clock switch this transistor on and will be start again to supply this transformer. Yes, it's a regulation. In between here, I don't know exactly what it's doing here, and here is the feedback line. This must be coupled by optical. This name is optocoupler, and have no galvanic connection from the primary side to the secondary side. You see? I make this test for this IC and came to the point this IC work, but the transistor don't work, as shown in the video. My new LCR meter is here. Well, I hope so. You can see it. You can see that good. We must switch to the 2K ohm, no, microfarads, yeah, 600 nanofarads, yeah, 200 nanohertz, so 10 nanofarads here. Switch it on, and we must connect it here and here. And what's happened? It's 10.3. 2 nano, no, cannot be. Nothing. Oh, we must switch here, see. 8. If I switch here, not 10. Is this in the tolerance? It's interesting. It's 8 nanofarad. Okay. What does that mean? 8 nanofarad? Is that good or bad? We must have a watch and a plan. What we're gonna do now, we build in this cap, and for the blue one, it's a bigger one, but okay. And then we check out disconnected every time. Don't forget this from the mains, and we must check out what's happened then. It's interesting. Power supply failure with no failure. We put this in, and then it works. Oh, could not work. I think so. This is only for what is this? A starting capacitor. Solder this now in. Okay, looks like good. Cut this off. Cut the legs off. Put it in. And put this again in. But first we would like to measure the connection between here and here, and if it's good or not good. Yeah, this is our interest. We go to the ohm. Say this here. Oh, the camera is warming. Super. It's not only me warm. Look at this. And here. Nothing. No. What's this? 9 ohms. That's a lot. And on the other side, nothing. This is this. This is the other side. Okay. This is this side. And it should come to the rectifier or not. Oh, it comes here and to the other side. No, there is nothing. With this transistor have a big problem, big issue, huh? Interest. What I'm gonna do, I build out the transistor from here, and this transistor is now inside this measurement thing, and if I press here to test, it took longer than normal transistor, but now look, it's only a diode. It's no transistor available. I'm shaking this a little bit, close it, measure it again, and we must wait. The analyzer is coming. It's a diode again. But why is a diode? It's interesting, huh? I think maybe it's interrupted in one side, and don't supply this transformer here. This is my problem. This is an issue. Look at this. I'm going to connect to the flip-flop. This is a flip-flop here. I'm connecting impulse. This impulse is a sinus, yeah? Look, this sinus here. And this is on the clock input. And here's the output from the transistor. It's the basic, it's the base input. And if I doing the data, this is the data pin to the minus. You see, it switched. That means the IC working. Low. This is the data pin. If I put a low in, it needs low. If I put a high in, it's high. You see? But I don't do that. It's the clock what is lifting inside the flip-flop. Now you see that. That means the IC is working. I order a new transistor, and the thing is this. I put it here inside this little measurement thing and started to measure. And what happened? What's happened here? Oh, it's an N-MOSFET transistor. Yeah. In case of the other transistor that I built out, that are disassembly, we have another measurement value. One moment, I put it here. We must wait long time for this transistor. It's coming from far, far away. Here is the original transistor, and I would like to show you this. And if I put that in this little measurement thing, close it and measure it, then nothing. Only a diode will be measured. I think it's defect. Okay, we put it here, and I would like to build it in. Soldering iron is hot, and I must disassemble all my measurement things here for the thing. It's okay. What's happened here? Okay. This happened here, this integrated circuit, and here is the transistor, you see. We put that in. The point is that the gate is number one. The gate is number one, and we must build it into the gate. Gate is here with the resistor. You can see this. That means it's in this direction. Okay, we have it here now, and now we must solder it in. We have that here. Solder the gate first. Then I think so the source or drain, and then the drain or source, I don't remember. Okay, looks like nice. And taking these pliers. Hope so this is working again. And I'm cutting the leads. Leave it out. And we must desolder also this wire what I connect here. Desolder it. Desolder it, and hope so there is no short. You have also the problem if you are doing an experiment here, can making a short and no good. In that case, I repaired that a long time ago. It was so. I hope so. That is working now, and I must build it inside the machine itself. The capacitor I changed. That was here, this capacitor, but yeah, I change it in case of that is often defect. So my friend told me that, and now we must put it in. So I'm not so. I cannot move. So click, making click, and here we put the screw in, and then we make a test. I hope so it works. The secondary power supply was not in operation, and then the idea comes, okay, super, it looks like good. And now we must switch it on, and I hope so it is working. In that case, that the transistor is maybe defect or one other thing is defect. I hope so. Now it's on. No, it's not on. Doesn't work. What shall I say? There is something wrong. But what? Power supply doesn't work. Maybe the fuses is wrong. The fuse is defect. Eventual fusing is defect. I must measure it. Here we are. We go into the Beepsy. Beepsy, please, what do you say to this? Disconnected from the mains, it's important. Okay, this fuse is okay, and this fuse is also okay. But no reaction on the power. What can that be? No click, no reaction. Is it in operation or not? Or maybe we disconnect something? No, it's all is connected. What we can do in this case? I found out also spare parts this 4013. I would like to change also this IC here in case of that doesn't work correct or so. I mean, there is no modulation on it. Maybe I cannot measure because I don't have a transformer to have the galvanic split from the mains. This is also an issue what I have. And yeah, that's not cool, but okay, what shares? Zack. I mean, it's not so easy to understand all that. Why this is not working in case of that there is no parts inside. I mean, where are the parts? First of all, I would like to resolder it for that point that I can desolder it. I'm doing this now with this pin by pin, and then we I hope so this is defect. In that case it never runs. What is here now? Maybe also the little diode is defect. I don't know. There is a little diode I remember, and maybe this is also defect. In that case, I hope so it isn't, but okay, it could be. And then the IC is okay, but I change it in that mind that or in the thinking that it's gonna be also defect in during the transistor is blowing up and so on, and they are on the gate. Maybe on the gate came out high power. Look, the new 4013 is the number of this IC. And the feeds are bent, but in the wrong direction. I hope so. I have this now. Yes. Maybe it's defect. I don't know. I can't measure it in case of I don't have a transformer to split my oscillograph from the mains and to isolate it. I mean, it's important if you measure on the power side, on the power supply, that you have a isolated measurement instrument. This is very important. In case of that you're blowing your fuse or your FE. This is also cool. Look at this. Now it's finished. I hope so it is working now. We can hope. We hope so. If it's not, then I don't know what I shall change. Maybe this little Z diode can also be defect. Oh, for what I shall install this. Maybe it's important for the grounding. It could be, but it must not be. Could be. Hope so. This is coming. Sus. X. So now we make the next. The next control is running or not, or blowing the fuse or whatever, making boom. Then we know more, not more, but a little bit. It's now running. Why? We should measure if the power supply is coming or not, or I change the capacitor back. This is also an interest point. I'm changing the capacitor back. Maybe it's the wrong capacitor. Maybe with this doesn't start good also. Okay. Oops. change it back to the... Oh, I know one thing. I found one thing. Look. I change it back to the blue one. And I found one. Look at this. Look at this transformer. The transformer is in the air. Oh my gosh. The transformer is not connected, so hey, come on. I change maybe parts in case of nothing. Okay. Transformer is in the corner. So we should solder and close the transformer side on both sides. Look, here and here it's open. I'm very sorry for that. Yeah. Maybe it's working. I changed a lot of parts and then it's the transformer did not. I mean, hey, come on. If you do it not safe, you cannot imagine this is what happened. I forgot this solder line. Okay. Maybe it's working now. If you have a contact on the transformer, it would work better than if no contact there. You don't have a contact. Maybe it's working now. Oh my gosh. And click! Pure direct, cool. Number one, man. If you don't connect the transformer, it cannot work. That's for sure. I mean, okay, super. I install all this now, and then we make a control over it that it's working and stuff like this. Now I must connect it to the power, I hope so. It's disconnected. Don't connect the amplifier if it's on the mains. It's not good. If you have a contact with it and the power and the supply is high, then you have the issue with your fingers, because this high voltage may be on it, and this is not good for you and for the amplifier also not good. And we need an antenna where we have a cable. It's also interest. My cables are gone. I'm alone here and my cables are stolen all the time. We have here. I mean, why? I think so. It's a chaos. It's the chaos theorem. Now we have it here. You can see that. And now what is here? I mean, this cable is long enough and now the cable is too short. So what happened here? We're doing now the radio station. One moment. Okay. Start up. What is now? It's the wrong cable or what? No. Cannot be. What is here? Here it is. Here we have the cable. Aha. Maybe it's the capacitor defect. This could be. I hope so it's not now totally defect. This is interesting. Why I have this big issue? It's angry, hey, come on. It's angry, come on. disconnecting the power lead, power supply, and connecting this here, disconnected. And now we build out the... Hey, come on, what is here now? I hate this. If a machine is working 1 second, the next one is dead. How that can be? I mean, these are all old. You're old. So put that back. The red one, I'll put it back.
Now we would like to have the information from the processor side. I repaired the power supply, and this plus 10 volts is here, and the plus 5 volt is also here, and the reset is on high, or 5 volt is coming here and here to these pins. The 10 volt is here. This capacitor is the Q200 is for the 10 volts. And now I check up this standby pin here. Yeah, you see that? This is number 1, 2, 3. 1, 2, 3. I check up this now, and you see it will be switch.
In that case, we measure the voltage of the secondary power supply, and it's 10 volts, a little bit more. We measure now that what we see on the plan. First, you can see the measurement instrument. I have the plan to do this here, and we measure here, and you see the 10 volts are coming. Yeah, it's good. And here 5 volts are stable here and here. New 5 volts is a high. The reset is coming. So now 1, 2, 3. Here is the standby button. Look, we have here 8.9 millivolts. If I press the button, 0. It switched to ground. I release 8.9. It is switching, but there is no power, no in to the pin, and that happened here must be the failure near here. What is this here? 5.6, 10, and out is 6 volts. Okay. One interesting what I found out is that on pin 62 the processor will have a voltage from about 5 volts. You see? And here the oscillation will not run. The oscillator is on one side high, on the other side should be 16 megahertz. Also the 32 megahertz clock are also not running. If a processor is in reset, normal the clock is running. This processor is not in reset. You see the high here on the reset pin. Why is that so? It's interesting, huh? Maybe I have a clock oscillator with 16 megahertz and we can kickstart it or so. This is also a possible way. That was the Yamaha RX-E810 that runs twice after my repair from the power supply. Transistor was defect, and I would like to bring it to run, but incidentally, the thing is that that's the processor never running. Yeah, I don't know why. The clock is not running. The crystal have no. One is high and one is low. One side is low, and yeah. What shall I do? If the processor never runs, this machine cannot never start again. Yeah, this is an issue. This is the second issue. What we found out, that if you repair once, a second failure can occur. Yeah, this is, I say I'm sorry, but I cannot fix it in case of that the processor not running. 5 volts are exist on pin 62 and pin 16, the VCC with 5 volts. But incidentally wise, the reset should be high. It's also high. Hold signal is high. And other signal, I don't found what's happened with this. If somebody knows what's happened with this, with the processor clock, interest-wise, the 32 kilohertz is also stopped, and the master 16 megahertz clock is also stopped. I mean, I don't know what's happened with this. Power supply is here, ground is here, all is here, but we don't have a power. No, we don't run with the processor. If you're interested in my channel, please subscribe and or sponsor me by patrons or at patrons, and thank you for watching.